Machu Picchu lies on a steep mountainside of the Andes at an altitude where simply standing securely is already a challenge. Heavy rainfall, dense mist, frequent earthquakes, and constantly unstable soil and rock define this environment. By modern construction standards, this is a location that would almost certainly be rejected from the outset. Yet, more than 500 years ago, the Inca did not merely choose to remain here. They built an intricate stone complex composed of residential structures, temples, agricultural terraces, and a sophisticated water management system. What makes Machu Picchu a subject of scientific interest is not mystery or beauty, but endurance. While many modern structures deteriorate after only a few decades, Machu Picchu has remained standing through centuries of intense rain, landslides, and seismic activity. The central question, therefore, is not what Machu Picchu looks like, but why it has not collapsed. To answer that question, Machu Picchu must be understood not as a ruin, but as an engineered system designed to survive in an extreme environment. The Inca did not regard Machu Picchu as a structure placed upon a mountain, but as a component integrated into the mountain itself. From the beginning, they understood that the greatest threat to any structure in the Andes was not wind or altitude, but water. Prolonged heavy rain softens soil, reduces friction between geological layers, and creates conditions for landslides. For this reason, the first step in constructing Machu Picchu was not erecting walls or stacking stones, but restructuring the ground. The Inca excavated deeply into the mountainside, removed weak soil layers, and then deliberately stacked multiple layers of materials in a precise order. The lowest layer consisted of large stones to form a load-bearing framework, followed by smaller stones, then gravel, and finally compacted soil. This multi-layered structure allowed rainwater to percolate rapidly downward and drain through natural channels rather than accumulating within the foundation. As a result, the foundation of Machu Picchu was not a solid mass, but a vast, hidden drainage system beneath the surface. Studies indicate that more than half of the construction effort at Machu Picchu lies in these unseen elements, demonstrating that long-term stability was prioritized over visual appearance. Once the foundation was stabilized, the Inca began working with stone. But their approach differed fundamentally from modern construction practices. They did not attempt to produce uniform stone blocks. Instead, they focused on ensuring that each stone was precisely suited to its position. The granite in the region is extremely hard and difficult to cut with primitive tools, but the Inca exploited natural fractures in the rock, using wooden wedges and water to split stone along desired lines. The stones were then shaped by repeatedly fitting them together until the contact surfaces matched perfectly. Each stone had a unique shape, yet when placed, it interlocked with surrounding stones like a puzzle piece. This technique required no mortar while still producing highly stable walls. More importantly, these walls were not completely rigid. During earthquakes, the stones could shift slightly, dispersing seismic energy, and then return to their original positions under gravity. Instead of cracking, the structure effectively breathed with the movement of the earth. This was an earthquake-resistant strategy based on controlled flexibility rather than absolute rigidity. The construction of Machu Picchu also did not occur within a short single phase. Architectural evidence shows that the site was expanded and modified over time. Certain terraces were reinforced after use, some walls were adjusted to improve drainage, and certain areas were rebuilt to better suit real-world conditions. This indicates that the Inca did not view Machu Picchu as a finished product from the beginning. They treated it as a system requiring ongoing observation and refinement. Each rainy season provided information about structural weaknesses. Each small crack served as an early warning. Rather than ignoring these signs, the Inca intervened promptly, modifying the structure to improve resilience. This approach closely resembles modern scientific methodology, in which systems are refined based on empirical data rather than initial assumptions. Agricultural terraces provide a clear example of the Incas' multifunctional thinking. On the surface, the terraces served as farmland, supplying food for inhabitants. From an engineering perspective, however, they also stabilized the mountainside, reduced slope steepness, and dispersed the force of rainfall. Each terrace functioned as a shock-absorbing layer, slowing water flow and preventing erosion. Beneath the terraces lay drainage systems designed to safely channel water away. As a result, agriculture and structural protection became two aspects of a single integrated solution rather than separate objectives. The water distribution system of Machu Picchu further demonstrates advanced hydrological understanding. Water from mountain springs was directed through stone channels with carefully calculated gradients, allowing continuous flow without causing erosion. Fountains and distribution points were placed strategically to supply domestic water without overloading the system. During periods of heavy rainfall, excess water was quickly diverted away from residential areas. Notably, this system relied almost entirely on gravity without complex mechanical devices. The design was simple yet highly effective, perfectly suited to the technological limitations of the era. Another critical factor in Machu Picchu's development was labor organization. Transporting and placing massive stone blocks required coordinated effort among many individuals. Without wheels or large draft animals, the Inca relied on human labor, levers, and inclined surfaces. This demanded a tightly organized workforce in which each individual understood their role. Construction would have been impossible without synchronized cooperation among groups responsible for quarrying, transport, placement, and finishing. Over time, accumulated experience improved efficiency, allowing later stages of construction to proceed more smoothly than earlier ones. Importantly, Machu Picchu was not built to display immediate grandeur. It was built to endure. Every engineering decision aimed to reduce long-term risk. When a solution proved ineffective, it was changed. When a structure required reinforcement, it was reinforced. This adaptive mindset allowed Machu Picchu to evolve from an initial settlement into a stable system capable of withstanding harsh environmental conditions for centuries. Viewed as a whole, the construction and development of Machu Picchu were not random acts, but a continuous learning process. The Inca built, observed environmental responses, and adjusted accordingly. The site did not remain static over time. It evolved alongside the growing understanding of the mountain on which it stood. This evolutionary process is the key reason Machu Picchu has outlasted the society that created it. Machu Picchu was not abandoned because it failed technically. It was abandoned because the society that sustained it collapsed. When the Inca Empire fell, people left, yet the system they had built continued to function. Water still flowed correctly, foundations remained stable, and walls continued to stand. This demonstrates that science and engineering, once embodied in well-designed physical structures, can endure far longer than political power or ideology. Today, Machu Picchu is no longer a living settlement or ceremonial center, but it has become a living document for modern science. It raises fundamental questions about how humans build in extreme environments, about the relationship between construction and nature, and whether we are attempting to resist our environment or learning to coexist with it. Machu Picchu does not tell a story of miracles, it tells a story of thought, and that way of thinking is the most enduring legacy the site has left behind.